robot teacher. How's that? Yeah. All right, so today is the 25th. Do you guys know that you don't have school on Friday? That's neat, huh? I decided that I think when I was writing stuff down last night that I would call these change word problems. I have 2 examples for you today and then a single page worksheet with 6 problems. And if apparently I didn't make myself clear last time, these do me no good if there is not organized, presentable work when you turn in your worksheets. If you don't know why, come see me and I'll explain it to you in massive detail. So I'm going to type again because I think that that's better for all of us, quite frankly. So as was the case when we learned these before, I'll give you a minute or two to get caught up and copy things down. So as you write, I know, you're probably just going through the motion of copying, but as you think about what you're writing, you understand where the change comes from. Is that we don't just have a rectangle, we have a rectangle and we change the rectangle and talk about that one. And so that's what today is all about. There's 6 problems on today's assignment. Only 3 of them are like this, and the other 3 should be more in line with what you're accustomed to, I think. So I don't see any issues with you knocking this out today. These are just new. And then there'll be some new stuff tomorrow. We're going to talk about consecutive integer problems. And then we still have to talk about age problems. And those notoriously are a little bit rough. They're also change problems. Yeah, so we'll save that for Thursday, I think that is. Today's Tuesday. Yeah, tomorrow's consecutive integers. And then Thursday will be the age problems. And those are interesting, to say the least. And then that should do it, I hope, for what we need to go over on word problems. Take another week or so, and then we'll test it and be done. So good strategy to right out of the gate, and I said this before, is I think to make a little picture. So I'm going to make a picture of a rectangle, and I want the rectangle to reflect what the picture says. And the picture says that the length is 7 more than the width. And so I don't want it to look like a square. I want it to look like the length is longer than the width. Bless you. So when we read that first sentence, that's going to be our relationship sentence where we figure out who it is we want to define. So in that sentence, who are we talking less about? The width, for sure. And we can switch variables today. We've been using X for everything. Let's get a little bit different here, and let's call the width W. And we obviously want to define him because he's the one that's not being talked about. So what would we put for a label then on the length? W plus 7. Good. It's okay if you used X, it's no big deal. This is a contextually specific variable. So if we were doing like the number of ice cream cones, we might use like C for cones or something like that. Good so far? All right, and we definitely want to label all 4 sides. And so there's another width over here, and there's another length down here. And now it's time to see where the word change comes from. So what's going to happen now is we have to make the changes that were called for in the problem. So what happens first off? Who changes and by how much? Very good. And so the length, if the length is right here, I'll put a little red box around it, and we decrease that by 5, what would it now be? It's okay. Go ahead, Bryce.
W plus 3.
Yes, because it used to be W plus 7, right? And I'll just make a little note over here off to the side. It used to be W plus 7, but we take 5 away from that. And when you combine those like terms, you can see that the new length is actually only W plus 2. Does that make sense? So maybe I should switch colors here. And so the things that I write now in blue are dimensions of the new rectangle, if you will. So his new dimensions are only W plus 2. Who else changes and by how much? And so if the width is currently W and he gets decreased by 4, what's his new name? Definitely. So the new width is W minus 4. All right, so the old length and the old width, we'll come back to those. So let's make a quick variable declaration. And I'm not sure I like the way I taught this last year, so let's try a simple approach. And if this doesn't work, then I'll go back to what I did before on example number 2. So for our first variable declaration, we definitely want to say let W equal width. And then we want to let W plus 7 equal the length. Good so far? All right, so what's written in blue is going to be what gets us through this, because the problem tells us that after we make those changes, the changes that result in what's written in blue, we get a perimeter of 40. So we're going to write an equation not using the width and the length, but rather the new width and the new length. Anyone want to take a stab at what that's going to say? Go ahead, Bryce. You can, and that's not an equation, but that's what I did last year. And the fact that you said that makes me think maybe I was not as far off the mark as I thought. You can do additional variable declarations, and that is what I had them do last year. So let's be clear about something. I had not expected anyone to say that, for the record. These are the dimensions of the original rectangle. We all agree with that, right? If I go on now, like Bryce is kind of pushing me to do, and I make more variable declarations, I'll write them in blue. Bryce says, well, let's let W minus 4 equal the width. And I'm torn as to whether or not I actually want you to do this step. So you can kind of come along for the ride if you want to, or just kind of sit by and decide if this is how you want to go. And what would then the length be?
W minus plus 2.
Good. And I definitely want to label these just like I did in red up above. Bless you. I want to label these as like the new rectangle, right? So again, that's what I was wondering if it was going to be a part of today's lesson. And so I'm going to leave that there as a you don't have to do it kind of step, but let's see how you feel. So now back to my question. I need an equation. No more variable declarations. We're set, but what's an equation that I can write? Remember, the problem says after the changes take place, then the perimeter would be 40. We got this. What's that going to mean? No, not right, but a perfect wrong answer. And I know you can't hear that on the recording. So he said 2w minus 2 equals 40. And what we don't ever want to forget is that rectangles do not have two sides. There's another w plus 2 down here, and there's another w minus 4 over here. Right, Zane? You want to try that again then? Yeah, let's not jump ahead. I'm just going to go like this. How about top plus right plus bottom plus left equals 40. I'm worried if we skip a step here that we're going to lose some people, okay? That's as literal and just kind of out there in your face as I could possibly make that. So again, that is top, right side, bottom, left side. And we should all agree that those are the dimensions now of the modified rectangle after we decrease the length and decrease the width. Good. Now remember, as we go through this and when we're done, and it'll only take us about a minute to solve this. This is easy algebra from here. The algebra is simple. Once we solve and we find W, we'll be finding the width of the original rectangle. Don't forget that. That W stands for that. So now I'm ready for you, Zane. Let's do some algebra. I agree.
And then
I agree with that. And if anyone were to want to ask a question right now, like where did the minus 4 come from? It's a result of this 2 minus this 4, bless you, which is negative 2, plus 2, which is 0, minus 4, which is negative 4. We're just combining the constants together. We've done this hundreds. I can say that in the end of October. We've literally done this hundreds of times at this point. And now it's just a basic, simple two-step equation. What do we do next? Add 4, divide by 4, giving us W equals 11. Now, great. And so that's, remember, something that's pretty cool, but it's not what anyone asked for. So step 1 was to declare all those beautiful variables. Step 2 was to write this beautiful equation. Step 3 was to do all of this beautiful algebra. Step 4 now is to come back out of the problem and say, what am I doing here? So we're going to make a little answer box and say that width equals and length equals. And what is the width? 11 feet. Oh, 11 centimeters. Very good. And what's the length? Length is 18 centimeters. It's important to read the question now. And, you know, I did it this way because it's what the worksheet's going to do. But you can be more creative as a teacher. You can ask all sorts of questions. I could have asked you, what are the length and width of the new rectangle? Like, oh, that's easy. I can do this because I could just take the original width, which was 11, and take away 4, and that would be 7, and take the original length, am I saying this right? And take away 5, I believe it was, right? So you could easily use these to find the new dimensions if that's what you were being asked to do. But the problem does say, what are the dimensions of the original rectangle? So you can put a box around this and complete the 4-step process right there. Step 4 is done. Any questions about that? All right, let's do one more. This one is only mildly more difficult, but you won't even hardly notice it at all. So short lesson today. So going back to that last example, those second variable declarations are up to you. That was, I looked back at last year's and I wondered if that was something that I really needed for them to be doing. That'll make more sense as we do. The age problems have a lot of these changes in them. It'll be like Marcia is 5 years older than Dan. In 12 years, Marcia's age will be 1/2 of twice Dan's age. Or I mean, it's like, whoa. So there's a lot of this change coming down the road here. You'll see. And you decide as you go. You have to at least have your original variables, of course, declared. That's a non-negotiable step one. So there's my rectangle, and I want to assign some labels to it. So who are we going to label as our generic variable? The width again, right? It just so happens that the length is being described, the width is not. So again, we'll throw a W on the short side. That's by definition supposed to be the width of a rectangle, the shorter of the two. It's not a literal, like how wide is it if it were standing up, it's just the shorter side. What would the length say? Yes, 3, it says it right here, 3 less than twice the width. And you've done enough of these to know that that's like this, 3 less than, like that, twice the width. We know not to do 3 minus 2W. We're not rookies here. All right, now it's time to perform the change. Let's go ahead and declare some variables before we make the change. So we're going to let W equal the width. And of course, we already know we're going to let twice W minus 3 equal the length. And make sure we understand here, put a little comment that these are the dimensions of the original rectangle. All right, let's go ahead and perform the change. And the change is described as the length. So that's the top in this case. The length is going to be decreased by 3. What's that now going to look like? Yeah, it was already 2W minus 3, and now it's minus 3 more, which makes it 2W minus 6. Good. And what's going to happen to the width? So what's that going to look like? Very good. So again, for consistency, written in blue are the dimensions of the modified rectangle. And that's going to be the dimensions. Those are going to be the dimensions that we write our equation from, because we know how to read English, and that's what the sentence clearly says. If we make these changes, then the perimeter will be blah, blah, blah. So you don't need to label all 4 sides, but you don't want to pull a Zane on this one and forget that rectangles have 4 sides. So if you're the kind of person that's even mildly inclined to forget that, remember the bottom is also 2W minus 6, and the left is also, of course, W plus 2. From here on out, I would imagine that it would be pretty difficult to not be able to write an equation at this point. So we know that the perimeter post-change is going to be 34 meters. So let's do this. What's our equation going to say? Alina? Well done. There it is. New rectangle, sides added together, we're told would equal 34. Good job. And now it's time for some pretty, I think, basic algebra at this point. How many W's, when we put them all together, will we have? I agree with that. And -6 plus 2, -4 minus 6, -10 plus 2 is? Indeed. Combining all of our terms together, right? Add 8 to both sides, you get 6W equals divide by 6 and you get W is nice. So to be clear, we just figured out that the width, so this is, I'm going to switch colors here. So remember, W equals 7 is cool. That's the width of the original rectangle. So we can say originally the width was 7 meters. Is that correct? I believe, yes. And then the length is 3 less than twice that. What's twice that? Twice that is 14, down 3 is 11. So these are the dimensions of the original rectangle. And if you go back and read the problem, it says that we want the dimensions of the new rectangle. So I'm going to use yellow to show you what we're up against here. We want what I'm putting in yellow boxes because those are the modified. Those would be the length and width after we performed the modification. And that's what's being asked of us here. So these answers that I have written over here in red, okay, that's pretty cool, but they're not what we want. What we want are the changed ones. So what will the width be after the change?
9.
Very good. 9 meters. That's just putting 7 because we know W is 7. That's the game changer for this whole problem. If W is 7, then you can just put that up in that yellow box. And if W is 7 and you put it up into this yellow box, what's twice 7 minus 6? Is 8. So the length would actually be 8. And I don't like that labeling, but honestly, it's not going to hurt us. Do you know why I wouldn't like that labeling? Because the width is bigger than the length. And honestly, on this worksheet, it's not going to affect anything. As a matter of principle, it's not going to be specific like length is, width is. It'll just say like this by this. And so you'd be fine in this case. But as a matter of principle, as someone who has to sleep tonight, I'd probably go back and change these and say that the width is the one that's 8 meters and the length is the one that's 9 meters. I just feel better about that, but you don't have to. So that box signifies, as always, the end of step 4. Step 1 was up here. We defined some variables. Step 2, we wrote this beautiful equation. Step 3, we did some simple math. And step 4, we answered the question. Good, good. All right, that concludes that. I'm going to hand out the worksheet. And again, to be abundantly clear, notebook paper. Neat. This is not scratch paper that we throw away. It is work that is presented so that your teacher can see what exactly you did. Got it? All right.